All right, this takes us to the last question here. We've got the integral of cotangent of x. All right, this brings us to another comment about u substitution. Right. You never want to pick x as your u, because if you do that, then you're going to end up with just this, which doesn't really help you. All right, so what I'm going to have to do here is kind of rewrite my function. Cotangent of x is the same thing as cosine of x over sine of x dx here, right? So at least now I have a component that I can use to work with, right? So I mentioned earlier, if you don't see any parentheses, right? We have two parentheses here. We have parentheses x, but we don't want to use u equals x. So what I'm going to do is I'm going to let u equal to sine of x. Right, so you get cosine of x over u dx. If I take the derivative of u, you get du over dx equals cosine of x, which is great because I want to get rid of that cosine in the numerator. Oops. Right, remember that the derivative component is going to be used to get rid of the dx. Right, so we end up with cosine of x over u times d over cosine of x. Well, the cosines cancel, leaving you with the integral of 1 over u du. And if you look back at your notes, when you have 1 over u, this is going to be ln of the absolute value of u plus the c, and then we plug the u back in. So we would get ln absolute value sine of x plus c. Be my answer. I'm going to shrink this down so I can check my work. Or maybe just move it up. All right. All right. Checking, I'm just going to ignore that parenthesis, that absolute value. ln of something means that you take the derivative of the inside, which is cosine. Right. Take 1 over what's inside. That's the derivative of the inside. Right. So you get cosine of x over sine of x, which is equal to cotangent of x, which matches my original problem. So this checks out.